In this problem, we want to find the impedance Z, and we're going to use our problem-solving strategy entitled Combining Impedances and Admittances. And basically it says when you have elements in series, you combine them as impedances. When you have elements in parallel, you combine them as admittances. So if we look at our circuit, for instance, this is a start. Here are a couple of impedances in series. Let's call that one Z2. Here are a couple of elements in parallel. Let's call that Y1. And let's calculate those. So, for instance, Y1 would be 1 over 4 plus 1 over J3. So the impedance is 4. The admittance would be 1 over that. So this is 0.25 minus J.333 Siemens. And then Z2 is 4 plus J2 ohms. So there's the first step. Now let's redraw our circuit and look at what we can combine next. So here's Y1. Here's Z2. And here's the impedance Z. Now, here are two elements in parallel, so we can convert those to admittances, and we'll call that Y3. Here are a couple of elements in series. We're going to call that Z4. Okay. So, for Y3, okay, Y3 will be 1 over minus J3 plus 1 over Z2. So we have 1 over minus J3 plus 1 over, or let's see, this becomes 0.2 minus J.1. So 1 over Z2. Okay. So this is 1 over 4 plus J2. So then Y3 becomes 0.2 plus J.233. So here 1 over Z2 is 1 over 4 plus J2 is that. Now Z4 is 2 plus 1 over Y1. So we have 2 plus 1 over Y1 is 1.44 plus J 1.92. And that's 3.44 plus J 1.92 ohms. So now we've completed those combinations. Now again, let's redraw the circuit. Okay, so now on the top up here we have Z4. Down here we have Z3. We have an impedance J3 ohms here. We have an impedance of 5 ohms here. We have an impedance of 3 ohms here. And then we have Z. And now if we look, these two are in series, and we'll just call those Z5. So Z5 is J3 plus Z3, and this turns out to be 2 2.12 plus j 0.53 ohms. And if we look at it, Z3 was 1 over the Y3, so 1 over the 0.2 plus j 0.233 is 2.12 minus j 2.47. So now again, we've got that combined. Let's redraw the circuit again. Okay, so we got Z4 on the top. Now we have Y5, and that 5 ohm resistor, we're going to go ahead and convert it to a conductance. That'll be 0.2. So now we can combine these two in parallel. So Y5 is 1 over Z5, which is 0.444 minus j 0.111 Siemens. So then we'll call this combination Y6. So Y6 then is 0.2 plus Y5. And that's 0.644 minus j 0.11 Siemens. So now we can again take this circuit and redraw it after that combination. And now it'll look like we'll have Z4. We'll have, I'm going to go ahead and convert it to Z6 because they're in series. And we know that Z6 is 1 over Y6. So now I'm going to define that as Z7. Okay. So Z7 is Z4 plus 1 over Y6. If you recall, Z4 was 3.44 plus j 1.92, and we have 1 over 0.644 minus j 0.111, because here's 1 over Y6. So then Z7 turns out to be 4.95 plus j 2.18. Now we can draw our circuit, and we're down to the point that we can calculate Z. So now our circuit is this. So Y, which is reciprocal of Z, okay, so let's calculate Y. We've got two elements in parallel, is 1/3 plus 1 over Z7. So we have 1/3 plus 1 over 4.95 plus j 2.18. So then Y is equal to 0.5026 minus j 0.0746. And then Z is 1 over Y, which is 1.95 plus j 0.29 ohms.